Okay, here's question 5.2. Let's just do it here. It says this 3 times the sine of 2x minus 2 times the cosine of 2x equals 2 minus cos squared x. We're supposed to find the general solution, which means simplifying it a whole amount and making this 0 on this side. Well, the first thing you know you got to do is sine 2x is equal to 2 sine x cos x, and 3 times 2 makes this 6 sine x cos x. Okay, and what did I do here? 2 minus cos squared. Oh, I took 2 cos x and I changed it to 2 cos squared minus 1. 2 cos. Why? Because I saw this cos squared and I thought them things might cancel. Well, 2 times 2 cos squared is 4 cos squared. And 2 times minus 1, well, minus 2 times minus 1, that'll make it plus 2. So this part is 2 cos squared minus 1. I think I kind of left a step out a little bit there to get to there, but that's 2 cos squared minus 1, and that turns into minus 4 squared plus 2 when you do that. Okay, so what have we got? 6 cos x squared. And if we add 2 cos x squared, we're going to get minus 2 cos squared x here. And we take away 2. Hey, this thing's getting simpler. What if we divide everything by minus 2? We'll have cos squared minus 3 sine x cos x. Now I see if I factor out cos x, I'm going to get cos x by itself equaling 0. Now that's one of your solutions which you want. And the other one, when I see sine and cosine like that, that means I can get tangent out of that by just dividing by cos x. So cos x equals 0, we'll make that equal 0. But I've got cos x equals 3 sine x. I make this equals 0, and I add 3 sine x, and I'm thinking, oh, if I divide by cos x on both sides, good things will happen, because sine x over cos x is tan x. And if I divide both sides by 3, 3 divided by 3 gives me 3 divided by 3 is going to give me 1. It cancels here. And over on this side, the cos x divided by cos x equals 1. But there's a 1 over here. That's just 1 up in the top. 1 over 3. So tan x equals 1/3. And then all you do is you go shift tan of 1/3, and your calculator gives you one of the solutions. One of the solutions. And with tangent, it repeats itself every 180 degrees. So there's your general solution for the tangent one. And for cosine, the cosine of 90 degrees is equal to 0. The cosine of 90 degrees is equal to 0. But the cosine of 270 degrees is equal to 0 as well. So if I just go 90 plus k times 180, I'll get all the possible solutions for cos x equals 0 at 90 and 270 and any kind of combination of it like that. Okay, so minus 90 anyways. You get all the answers there. Maybe we'll try the next question here. Prove that this tan squared plus 1 over tan x equals 2 over sine 2x. I found this one a little bit tricky, but the first part to get started, tan is sine over cosine. Tan x is sine over cosine. You get marks just for doing that. And then it's all about fractions. What do? You tip and times. You tip and times. So this turns upside down here. Well, if I multiply it through here, cos will cancel with one of these coses, and the sine x will multiply. You'll get sine x cos x. Now, I'm feeling pretty good about that because 2 sine x cos x gives me this thing. So that's kind of part of the story. The cos x over sine x times 1 is this. Now I'm looking at fractions again here. I've got sine squared here. I've got sine x cos x. I'd like to add these. What do I need? A common denominator. So it's all about fractions. And then sine squared, if I multiply the top and bottom of this by cos x, I'm going to get cos squared here, and I'm going to get another sine x cos x, which is just what I want. It's really good. So watch this. I multiply by that. I've got sine x cos x on both sides now. But sine squared plus cos squared, oh, that's one of my excellent identities. It's 1 over sine x cos x. Now how am I going to turn this into 1 into 2? Well, I can multiply the top and bottom of a fraction by the same number. Ooh, I think I've done it. There, the 2 and 2 sine x cos x. Hey, that equals the right-hand side. So I've worked it all down and I've made it equal the right-hand side. And there you go.